Good day, friends. Today's class, we still want to solve more problems on stoichiometry, and this question, you need to pay attention till the end. We have JAMB 1991 question 3. An iron ore is known to contain 70.0% iron 3 oxide. The mass of iron metal, which can theoretically be obtained from 80 kg of the ore, is, let's write the equation of the ore in this and see the options we are given and the relative atomic masses. Before you can solve this problem, you need to write the chemical equation. So let's write the ore. That's iron 3 oxide. Let's balance it. We give iron with oxygen. So iron is 2. Let's put 2 here. Oxygen is 3. Oxygen is 2 here. Let's put 3 here. So this will become 6. So oxygen is only 3 here. This will become 2. So we have 4 of iron. So we put 4 here. So the equation is balanced. 4 iron, 6 oxygen, 6 oxygen. So what we need to compare is just the iron oxide and what? The iron. So we are given 2 moles here. Gives 4 moles here. But don't forget, we are giving in terms of mass and mass. That is the only option. That's the only thing. We are giving that the mass of iron metal, which can theoretically be obtained. So mass and mass. So let's get the relative molecular mass. Let's get the relative molecular mass of iron oxide. So let's get that one. That one will give you 2 into bracket. So this 2 here into bracket. This 2 here means 2 times 56 plus 3 times 16. So let's evaluate that. 3 times 16 is 48 already. So let's quickly do that. So we have 40, that's 56 times 2. 56 times 2 is 112. Is 112 plus 16 times 3, that's 48. So the addition of everything is 160 times 2. So we have 320 grams. So 320 grams of iron oxide will give us, so we have 4 moles of iron. That's 4 times 56. It will give you this 4 times 56. So 4 times 56 is 224. 224 grams. So 224 grams. So the question says an iron ore is known to contain 70.0% of iron oxide. There are some things you need to know before now. If let me solve it here. If 100 grams, if 100% of iron oxide, if 100% of iron ore gives you, we have can theoretically be obtained for 80 grams of the ore, give you 80 kilograms. That's the best way to do that. Then 70% of iron oxide. Iron oxide is in the ore. The ore is the total impurity, is the total material, but the iron oxide is in the ore. So you now have 70% of iron oxide will give you, let's call this place maybe A. So if you cross multiply, what will be left here is that we'll be dividing by, we have 70 times 80. 70 times 80 divided by 100. So what I'm doing now is 70 times 80 divided by 100. So 70 times 80 divided by 100. So we have 56. So this one here is 56 kilograms. but we can't put 56 kilogram under iron oxide. This is already in grams, so we need to convert 56 kilogram to gram. So when we convert it very well, that means we are multiplying by what? 1000. 1000 gram is 1 kilogram. So 56 kilogram would be 56,000 grams. So that will give you 56,000 grams of iron oxide. So 56 grams of iron oxide is what I'll be putting here. So we have 320 is 224 grams. So we have 56,000 grams will give us X. So we want to calculate the X gram of iron that will give you 56 grams of what? Iron oxide. So if we cross multiply, so that means I'll be multiplying 56 and 224. I'll be dividing by 320. So let's do that. Let's do that. So we have 56,000 times 224 divided by 320. So we have 39,200 grams. But if you see, the solution is in kilogram. I need to divide back by 1000. So if you divide this one by 1000, you are left with all the 2 zeros cancel. If you are dividing by 10, means you move once. So that will be 39.2 kilograms. So the solution is option B, 39.2 kilograms. Hope you have gained something in this video. This information I have shared is very, very important. You will need to share this information and let it go viral, so that students that are writing exam in few weeks will be very grateful for sharing this information. See you in my next video. Bye.